Hi, I'm Raj.
I'm Real. I'm Chai.
I'm Hong.
And Zito.
I'm Hong. I'm going to discuss about the stirring cycle. Stirring engine uses the principle of stirring cycle instead of the Carnot cycle, where the isentropic part of the Carnot cycle is replaced by a constant volume regeneration in the stirring cycle. Okay, here's the TS diagram for the stirring cycle. You can see here. Okay, starting from point A to B, here is the constant temperature compression, where the temperature here is known as the low temperature, which means the temperature here is the temperature of the cold workplace. And then from B to C here, now this part is the constant volume regeneration part, where the internal heat will be flowing from the generator to the working fluid. C to D, here is a part where it's the hot workplace achieve the highest temperature here. This is the constant temperature expansion. Then from D to A will be another constant volume regeneration, but here the heat will be transferred from the working fluid to the generator instead. And so the comparison between the TS diagram and the PV diagram is is the same actually, just that the shape is different. C to D here, the temperature is unchanged. For here is a high temperature, and here A to B is the low temperature. And then the calculation of the efficiency for stirring cycle is almost the same with the Carnot cycle, where the efficiency is equals to the high temperature minus low temperature, then overall divided by the high temperature. Or we can write it like this: eta equals to 1 minus TL over TH.
The main component of stirring engine, first of all, is the power piston. The power piston is a small, tightly sealed piston, and it will move upward when the gas inside the cylinder expands. And the second one is the dispenser. The dispenser is the larger piston, and it is loose in its cylinder, so that the air inside the cylinder can move easily in the heated and cooled region. This piston will move action by the compression and expansion principle. Different in the pressure cause the piston will move and produce some power. Actually, how the steering engine works? One side of the cylinder is continue heated and another side of the cylinder is continue cooled. And the air, first of all, the air will move in the hot region. The air inside the hot region will expand and move and push the dispenser upward. After that, the air will move to the cooler region. And the air will be cooler and it will push the dispenser downward. So this cycle will continue and make the steering engine work.
Greetings. For our project, we have built a few prototypes of stirring engine, beta stirring engine, but the first and the second one, we failed to move it. But for the third stirring engine, after we have made some adjustment, it can move freely afterwards. Okay. The reason why we fail is because of the crankshaft. The dimension of the crankshaft is not correctly bent, or maybe this is too high. And another one is our displacer inside here, the steel wool. It may be because of the leak of the gas from the heat region to the cold region. And the third one is our piston. As you can see at here, the piston does not move freely. When it moves upwards, it has some tension, and move downwards, it has some compression. Too much. So this is why it fails. Okay, now I'm going to start our stirring engine. Okay, you can see it here. Our heat source is 2 candles, which we can improve the RPM of the flying wheel by improving the heat source, such as Bunsen burner or alcohol. Okay, but what we discover here is some difficulties, which is our crankshaft. is too soft. When it moves, you can see it will slightly bend downwards, although we have bent it 90 degrees already. As you can see, our flywheel is turned on clockwise at this position. This is because our crankshaft is bent like this. When the crankshaft is at the bottom, this part will be bent 90 degrees towards upwards from this direction. So when this move, the connecting rod at here will move with the aid of the weight of the displacer, which is the steel wool. So our steel wool must have the medium weight, not too light or not too heavy, because too heavy it will disturb the speed also, or maybe it can move. Okay, we are thinking about to build a cogeneration system. That is, our heat source will boil the water and our flywheel will generate electricity.
Greetings. So, after we finished our project, there are actually some parts and components where we see could be made adjustment to improve the efficiency. Right, so the first thing, let's look at the heat source. So for our project, the heat source we use is a candle. So next time, for a maybe more eco-friendly approach, we could use solar energy instead. So we could use the concept of magnifying glass, focusing the light intensity onto the heating chamber to provide the required heat. Right, next, let's look at the upper part of the cylinder. So how the Stirling engine works is through the difference in temperature within the upper region and the lower region of the engine itself. So in our case, what happens is, after a while, when the temperature balances, then the engine will stop. So maybe we could introduce a piping system where fluid will flow through the upper region to keep it cool, or just simply attaching a cooling tank at the side. Right, next, let's look at the lower part. So basically what the lower part needs is a material which conducts heat more efficiently, so that the process of heating could be accelerated. And besides that, the crankshaft. So for our case, what happens is, every time every round we run the engine, what will happen is the crankshaft will bend. So next time maybe we could use maybe a metal rod which is more tougher. Okay, so last but not least, the cylinders itself. So very similar to how the 4-stroke engine is more powerful than this 2-stroke engine. If we were to increase the number of cylinders connecting to a single crankshaft, this would actually provide a higher efficiency. Right,
As we know, in life, everything has its advantages and disadvantages. So let's first talk about the advantages in Stirling engine. So the first point is silence of operation. Now, why I'm saying it's silence of operation is because there's no expansion in its atmosphere when it comes to Stirling engine. Not like other internal combustion engines, for example, spark ignition engines, where there is an expansion in its atmosphere. Plus, the design of Stirling engine makes its vibration that occurs in its whole design minimal. Okay, so the next point is high efficiency. Now, why is it high efficiency? It's because it is possible for Stirling engine to work in a cogeneration principle, where it's possible for you to achieve a mechanical and calorific powers. The third point is low emission and environmental friendly. Due to the external combustion that takes place in Stirling engine, there will be a reduction in its exhaust fumes. Now, we all know that exhaust fume can be very harmful to living things, right? Yes. And so, why is it environmental friendly? Just for example, if we are going to use biomass as its fuel, we'll be able to achieve a stable carbon dioxide energy balance. Point is applicable across a range of energy sources. Now, due to the factor that external combustion takes place in Stirling engine, now we have a variety of energy sources to run the Stirling engine. For example, such as energy sources that you can obtain from wood, sawdust, waste, and solar energy. The simplicity of the design of Stirling engine makes it very reliable, and you only need a little maintenance to maintain the proper structure of this wonderful engine. Now let's move on to the negative side of Stirling engine, which is its disadvantages. So first point is ignorance of this type of engine. Now why is this point highlighted? Is because compared to other types of engines, Stirling engine might not be as popular as other engines. So it's very crucial for us to educate the public about the importance of this engine. And now, moving on to heat transfer, we all know that heat transfers in gases can be very delicate. Therefore, we'll need bulky apparatus to run this engine. And moving on, it cannot start instantly. After testing out this Stirling, we have proved the hypothesis stated that the moment you heat up this engine, it takes a while for it to heat up, or in other words, to warm up. Okay, and moving on, which is the last one, lack of flexibility. After running this engine, we realized that variations in its speed or in its RPM is quite hard to be achieved. So, especially if you're talking about in an automobile type of environment, this engine can be quite troublesome.
So, in conclusion, our project of fabrication of a Stirling engine overall is a success. So, here we would like to say thank you to Dr. Philip for guiding us throughout the whole semester in applied thermodynamics, and I also want to thank all of my group mates for being cooperative, and I appreciate all of their help. That's all. Thank you.